f of 1 and f of 2. It's a really easy skill. You just got to think about where you can plug that in. F of 0, can you plug f of 0 into x squared? Can you plug a 0 into this third piece? Why not? It says you can't. It says I gotta be greater than what? 1. Which piece of that piecewise function can you plug a 0 in? The first one up top. Do you see that? It says so long as x is between -1 and 1. It's acceptable to put a 0 in. So we're just going to plug things in where they belong. Part A, f of 0 is found by plugging into this piece right here. -0 plus 1 spits back a 1. Pretty simple. Where can you put f of 1 in? The second equation. You really can't plug anything into, can you? Bryce, if you plug a 1 into the second equation, what's it going to spit back? A 2. That's what it does no matter what. It spits back a 2. And last thing is f of 2. Leah, where do you get to plug that 2 into? The last one. 2 squared. B is kind of an interesting problem. Determine the domain of this function. It's a lot easier if you actually have a graph in front of you, but you don't yet. But what you got to do is you got to scan through these restrictions on the right-hand side. That's what you got to do. Okay. This right here is telling you what the smallest thing x can be. It's saying the smallest thing x can be. It says -1. The first thing you read is that -1 is less than or equal to x, so that x is greater than or equal to -1. That's your smallest element of x. And there is an equal sign there, isn't it? As you jump through it, well, you see that restriction less than 1, but then the middle piece takes care of what happens at 1. So 1's in the domain. There's no reason to break it off. What's the last thing say? Greater than 1. What's greater than 1? 2, 3, 4. Where are we going with this? Okay, good, because I didn't have much time to come up. Okay. If you are not a fan of interval notation, you can use step builder. Maybe one of the two. The last one reads all values of x such that x is greater than or equal to -1. Part C is the fun one, graphing by hand. It's actually not that bad, especially if you just embrace tables. It's actually really easy. I got some free space here. Nope. So we're going to graph the 3 pieces of this function. It's not going to be hard. We'll do some things that you may wonder, like, why are you doing this? But we'll fix it when we graph. You do need to realize that when you look at something, what it is, -x plus 1, what is that? Line, parabola, V, R, it's a line, right? All I'm going to do is I'm going to plot 2 points. All I'm going to do is a line. I'm just going to do it with a small table. I'm not going to try and graph a whole entire line. I'm just going to make a small table. I'm going to plug the -1 in, and even though I can't be it, I'm going to plug that 1 in. I do that because I can get really ridiculously close to that 1. I can get to 0.999999, can't I? I may as well plug the 1 in. I can fix it on the graph by using open home. So it's not an issue to plug it in. I'm just going to plug in 2 points. If I plug in a -1, what's it spit back? 2. If I plug in a positive 1, what's it spit back? 0, right? So I get to plot the point -1, 2. That's a point that exists, solid dot. And I get to plot the point 1, 0. But does that point actually exist? Notice the inequality symbol here? It's an open hole. 1, 0 is an open hole. That's how you fix the issue of not actually being able to plug the number in. You just say it's an open hole. There's nothing actually there. So we graph that piece. Pretty simple. Now you can use y equals mx plus b here, but I'm telling you, they really do. The next one, if x is 1, what's y? I really don't feel like writing the table out for that. If x is 1, y is 2. Solid dot with an equal sign. Third piece is x squared if x is greater than 1. Now, what does that look like? What's the graph of x squared looks like? Looks like a U. Well, the entire graph is a U. And we're not going to draw the entire graph, we're going to draw part of it, that's all. The big deal is that you kind of invoke the curvature of the problem. That's the big deal, just invoke the curvature of it. So when I make a little table for this one, I will start with that 1. Even though I can't technically be that 1, I will start with that 1. And if I plug a 1 in x squared, look at what I get back. 1. If I plug in a 2, what do I get back? 4. I don't know if we'll take this far, but if you plug in a 3, you get a 9 back. So 1, 1, open hole, which is nice. There's already, sorry, 1, 1's right here. Open hole at 1, 1. Right 2 up 4. And that's probably all I'm going to graph. Because I don't feel like sending the y-axis up to 9. Am I going to connect those 2 points with a straight freaking line? No. Because it's not a line. It's got the curvature of x squared. It's a piece of that graph. It might be kind of hard to do depending on how small you write, but just try to show a little curvature and it's done. All right, now go get a TI-84. TI-84 can do piecewise graphing. The issue is how you put it into y equals. I do not think it will actually be able to do the middle piece, though. We'll give it a shot, but I don't think it can do it because that's just a point. But it can do the other 2 pieces. Now, what you have to do is you have to wrap the entire expression in a set of parentheses. So I'm at y1, y equals, I'm at y1, and I'm typing negative x plus 1. The entire expression has to be wrapped in a set of parentheses. Then I'm going to open up a new set of parentheses, and I'm going to type out this inequality that's given to me. All right, has everybody got at least this? So negative 1. Now you don't see a less than equal to symbol on your keypad, do you? It's because it's not there. The inequalities are under second math. Above math, you see the word test. You see the word test above math? If you'll hit second test, you'll see the inequality symbol. So I want the less than equal to symbol there. Press enter. Now I can put my x in. Now I need the less than symbol. And again, those inequality symbols are where? Second math. And I want a less than symbol here. Now one thing a TI-84 won't show you is it won't show you an open hole. It can't do that, it doesn't have that ability. But if you've typed this in and you hit the zoom 6 button, I apparently have made a mistake. Where have I made a mistake? Oh, I forgot about this. TI-84 cannot handle compound inequalities. You have to break them apart. My bad. You have to break it into two different separate inequalities. I think, it's been a minute since I've done these. So what I did is I'm going to break this into two inequalities. One of them is that x is greater than or equal to -1. And the other one is that x is less than 1. Let's see what that does. Truth is, I never do these with technology. That fixed it. So there's the problem with the TI-84. I had to break that compound inequality into the two separate inequalities that it was, because it couldn't handle it all at once. You understand the breaking apart there? And if you do the break apart, you'll see that little line segment, which is all you wanted. I'm going to try and put this in here, but I don't think it's going to do anything. I'm going to say 2. I guess I need to wrap it in a set of parentheses. I'd be really shocked if it actually plotted a point for you. And the restriction here is that x is what? Equal to 1. I don't expect us to see anything show up. Although I could be wrong. That happens from time to time. Never actually tried to plot a point on a calculator. And as I suspected, nothing's there. Why? It was just a point. A point doesn't really exist. It doesn't have any dimensions. If you go back to geometry and you talk about the definition of a point, it has no dimension. So, no surprise there. But I can see the rest of it. Second one is going to be an x to the second. Restriction is that x is greater than 1. Now, I'm not showing you this so you can just copy this onto your piece of paper. Copiers never plot points. Copiers don't plot points. It's a dead giveaway you copied. Copiers do not plot points. They're too lazy for that. I'm showing you this so that you can look at what you draw and make sure it's right. That's the only reason I'm showing it to you. And there's the remainder of it. Window goes up 10, so it's a little more accurate than ours, but does ours look pretty good in comparison? Yeah. Ours is actually better. It actually gets to see that there's a point there. That's piecewise graphing. Was it so bad? No? Aaliyah, Aaron, how did Miss Dana teach that last year? Did she have y'all make tables, or do you remember what's one bit whatsoever? That's about it. But did she do tables? A lot of teachers don't. They just say, you know what this looks like. Imagine where it's at. Draw it. Tables make it way easier. All right, so here's the other one we're going to do. Another piecewise function. Then we have a word problem coming up, I think. So it's not going to be too bad. We're just going to make little tables. 2 minus x, we know that looks like ahead of time. What is it? A line, isn't it? What x values you want to plug into it? Yeah, 1. What's the first x value you want to plug into it? Maybe I forgot to mention, where did I get these two x values? From the inequality. The x values you get come from the inequality. It's a line. How many points do you need to draw a line? 2. So you plug in the beginning, you plug in the end. The rest of it takes care of itself. -3 and 1. Now, if you plug a -3 into 2 minus x, what's it spit back? 5. If you plug a 1 into 2 minus x, what's it spit back? 1. So let me give you negative territory. I get to plot -3, 5, and I get to plot 1, 1. Oh, open. And there's the left piece. You remember what the root of x looks like? Your arm. The root of x is the arm function, okay? It's half of a parabola turned on its side. That's the arm function. So you're kind of thinking that when you see it, it looks like an arm. It's a rough idea what the graph looks like, because you're not going to plot a whole lot of things. Plot a couple. So next up is root of x. What's the first value you plug into it? 0. Actually, let's just do all the key points for root of x. What are the key points for root of x? 0, 1, and what? 4. Because those are the first 3 things that you can actually take the square root of. I told you a lot of these things are common sense. Easy stuff. Root of 0 being 0, root of 1 being 1, root of 4 being 2. So we do have a solid dot at 0, 0. Kind of interesting, this inequality. We actually get to close the dot, the hole there, don't we? This thing's got issues. I bet that's supposed to be a negative one or something. That's a really weird looking piecewise function. It's actually not a function. Somebody messed up when they made that problem. It would be me. Functions are not supposed to cross each other's paths. But whatever, it's graphed. That's the gist of how you do it. Anybody got any, I didn't talk about domain and range, I don't really care. Anybody got any big issues with that? All right. I suppose we have a word problem yet. And this is how electric bills work. It's really cheap though. In Weaver County, I think this one says, of course, this is an old question, 2009, Duke Energy in Ohio. It says no matter what, you pay $4.50. In Weaver County, I think it's 15 something. Doesn't matter if you're using electricity or not. You pay a flat convenience fee. The fact that you have electricity, like 15 or 16 bucks. It pays for maintenance on the lines, kids. That's what that's for. Stuff's not cheap to bring out there to fix. But anyways, monthly charge of $4.50 plus 5.2345 cents per kilowatt hour for the first 1,000 kilowatt hours supplied in a month, and 5.3622 cents per kilowatt hour for all usage over 1,000 kilowatt hours in a month. And that happens. The more electricity you use, the more they charge you. The rate goes up too because you're a high demand customer. And it costs more to service you, so they increase the rate. All right, part A is what is the charge for using the first 300 kilowatt hours in a month? Well, that's pretty easy to figure out. What do you got to pay no matter what? $4.50. And for every kilowatt that you use, what do you pay? Let me rewrite this as a function. Cost as a function, we'll use K per kilowatt. It's $4.50 plus 4.2345 kilowatts. So all we got to do is plug in a 300 for the amount of kilowatts we use, right? All right, so I can't do that in my head. What's it going to cost for the first 300 kilowatt hours? Which, by the way, is not a whole lot of electricity. You guys done the personal finance class where you like come up with budgets and stuff? Yes, it is, because I'm using dollars there, aren't I, Gabe? Good catch. So you have done the personal finance class where you try and estimate your budget? Huh? Oh. You guys will mostly be watching the Dave Ramsey videos. I'm pretty sure that's how he teaches the course. But I always budget $200 a month for electricity. It's just what I budget. It's usually around that. Some months it's $220, some months it's $170. Just depends on what time of year it is. $17.20. I wish. I really do. Do not let this example guide you in the budget process, okay? Because it's incredibly inaccurate. All right, what is the charge for using 1,500 kilowatt hours per month? Well, what I'm going to do is I'm going to figure out the cost of the first 1,000. And I'm going to add to it the cost of the next 500, okay? You could do this in one kind of line here, but what I would do is I would figure out the cost of the first 1,000, because if you read the text, don't you pay a certain rate for the first 1,000? And a little bit over. So we're going to find the cost of the first 1,000 and then add in the cost of the next 500. So the cost of the first 1,000 is just done by plugging 1,000 in the equation that we have above, isn't it? I never did correct that decimal place in the equation. $42.35. Was it $46.85? Yeah. Should be $46.85. Anybody any issues with that? Makes sense. Then we're going to find the cost of the next 500. That's actually going to need its own little formula, isn't it? Cost of the next 500. Well, you've already paid $4.50. You've already paid for the usage for 1,000, right? So you just use the new rate. After that 1,000 kilowatts, what's the next 500 cost you? $500 times, or the number of kilowatts times what? 5.3622. So that'd be 500 times that. I'm not trying to confuse you. I'm trying to lay this out so that you see the piecewise function when we're done. Because that's part C. Write the piecewise function. I don't know what that is off the top of my head. $505.36. That seems wrong because I did the same thing I did last time. Decimal place. This was where I did the cost of the first 1,000. I am going to eventually add this in. I'm just not there yet. I'm not trying to do everything in one line.
But you type that in, we did 500, we're supposed to do 500 plus.
No, it's multiplication. Oh, I did, didn't I?
Yeah.
Well, that explains a whole lot too. 500 times. $26.81. So the cost of the 1,500 is at $46.85 plus the $26.81. That's 66, 72, 73, 66. I think it's 73.66. Somebody should probably check me on that. Huh? That's right? Okay. Now, the reason I kind of broke this all up is that you could actually see the piecewise function. I wasn't trying to do more than I needed to do on purpose. I was trying to show you the piecewise function. This is part C, and I'll have to get up and write that one out. But we're actually going to write the cost function considering the multiple pieces. Save X. In this piecewise function, it's got two distinct pieces. The first piece is where you use less than what? Or up to 1,000 watts, right? And that's this little function right here. Now this is an X function, not a K function. So 4.5 plus 0.042345X. You just have to have a restriction. What's the deal about X? What's it got to be less than or equal to? 1,000. It's the kilowatts used. It also has to be greater than 0. Okay? It has to be tracked between 0 and 1,000. That 0 is actually important.
Mr. Neal,
I forgot to take attendance, didn't I?
do you have anybody else?
Emily and AJ.
Emily and Asia. All right, thank you.
Thank you. The 0 has to be there, kids. It has to be there. You don't want something happening, a glitch happening, the customers get paid money back. The 0 has to be there. Okay? You can't use less than 0 energy, can you? Maybe if you have some solar panels up, and the company comes back on that. That's not the only one that's going to happen. Now, the second function, all we did was we added the previous amount, right? It's the 4685, because we know that 1,000 kilowatts is going to be used. We know that this amount is going to be $46.85. And then we added in the new rate, which is that one, 0.053622. We can't actually just put an X there. Because at this point in time, how many kilowatts have already been used? I can't throw 1,500 at this thing. I've already used 1,000. That's already been accounted for in $46.85. How much, or how many kilowatts have already been accounted for by the time you get the second equation? 1,000. So whatever X value you feed this thing, you've got to take away 1,000 from it. I hope that part makes sense. That 1,000 kilowatts, is it accounted for in the $46.85? That's why you take it away. Otherwise, you end up with a bill that's just hard than that. Now, the restriction on this is simply that X is greater than or equal to what? 1,000. There's your piecewise function for electric bill. That is how electric bills work, although they're usually multiple tiers. Usually 3 or 4 tiers on electric. Okay. All right. I spent some time on that, but that means you probably forgot half what I talked about in the beginning. Is there anything I need to go over? Other than me screwing up with decimals?
There's supposed to be 3 and 2 in these.
2, 3, 4, 5, 6. Piecewise just means pieces, doesn't it? That's all it means. There's no set number there has to be. I think this is probably the same problem on the next page. I just did it all on one page, didn't I?